Hi there, welcome to your lesson on triangle areas. Now look at this photo where this person is shocked to find out that the area of a triangle is 1/2 base times height, because the triangle is half the area of a rectangle. Well, I hope you already had this realization sometime in your life, but let's check it out. So here we have a rectangle, and we know the area of a rectangle is base length times height. And then you can cut that rectangle in half and have a triangle. So that's why the triangle area is half of base times height. Now let's look at another example, because maybe you're thinking, well, not all triangles are right triangles like this one. That's true. So here we have now a parallelogram. And in a parallelogram, the area is found also by doing base times height. And a parallelogram, just like a rectangle, can be sliced in half. So we end up with half of the base times height for one of the triangles. All right, let's get jumping into the topic here. We're going to look at triangle areas in a different way. So let's try it out. The question here is, can we find the area of the triangles below? So let's take a look real quick. We have this first triangle. And remember, if you want the area of a triangle, you need the base and height. Do we have it in this one? I think so. We're going to find the area by doing half times the base times the height. And in this case, we have everything we need. We have the base of 20 and the height of 8. We can find the area. Okay, how about triangle number 2? Yes, I think we have everything we need as well. We have a base of 9, a height of 8.6, half of that. We have the area. So with those triangles, we can proceed with just the basic formula. Let's go to number 3. In number 3, well, I see a base of 24. I see a height line drawn there, but the measure isn't given to us. But do we have the tools to find that height if we need it? I think so. So if I begin with half times base times height, I have this. Okay, there's the base of 24, height of h. Now, can we find h? Okay, let's think about the things we've been working on recently. Trigonometry, Pythagorean theorem, sine law, cosine law. Can we use one of those to help us find h? I think so. We could definitely use... So look at this triangle. What do we know about it? We know 3 sides. And if you remember what we learned about the cosine rule, if we have a triangle that's a non-right triangle, like this full triangle is, but we know all 3 sides, we can use the cosine rule to find any angle. So let's say we use the cosine rule here to find maybe angle A. And once we have that, we can then use basic trigonometry to find h. For example, if we knew angle A, we could set up a sine ratio. Sine of angle A equals h over 10. That could allow us to solve for h. And once we have h, we can then use the area formula. So a few more steps, but we could use the area formula. This last one, however, well, I see only 2 sides there. Once we know only 2 things about a triangle, we're kind of stuck. We always need to begin by knowing 3 things, unless, of course, it's a right triangle. And then if we know 2 sides, we can use Pythagorean theorem. But it looks like we're stuck. So this lesson's about looking for a way to find the area of a triangle that's a different way than this formula we've known for years. So let's get into it a little bit further. Let's begin with this investigation. So if you could sketch this triangle that you see in your notebook, we're going to do some investigating on it. And the first step in this investigation is, can you write an equation for the area of the triangle in terms of h and c? And so that you know, this c here represents this entire length along AB. So can you write an area equation for that? Well, I hope that one came easy, because it's exactly what we were just talking about. We have the area of this triangle found by multiplying base c times height h by half. Okay, so we have an equation in terms of 2 variables. Let's take the next step. Consider triangle BHC, and notice that BHC is this triangle here, not the full triangle, but this one here. Write an equation for h in terms of A and angle B. So can you write an equation for h, and in that equation we're going to have A and angle B. Okay, I hope you were thinking, well, if I need angle B and I need h, well, the way to bring those together is using a trig ratio, for example, sine. Because if we take sine of angle B, then we have opposite h over A. So that equation, well, it doesn't look quite like what this asks for, because it says write an equation for h. This is not for h. So we need to now rearrange this. H equals a times sine b. So that works. That meets the requirements of this statement here. Next step, substitute your equation for h, this one here, into the area formula above to create a new formula for the area of a triangle. Okay, substitutions are easy. Substitute this in here, and I hope you came up with this. This is a way to find the area of a triangle that uses trigonometry. And let me simplify this a little further. We have half times a times c times sine b. You'll usually see it written in this form. So again, here is a new way to find the area of a triangle where you do not need to rely on the value h. So if you just know two sides and some angle, you can then find the area of a triangle. So a powerful formula because it allows you to use an angle and not to need the height. Let's apply that formula. But before we apply it, let's show, like we've had with the sine rule and the cosine rule, you can write it in all kinds of ways, depending on what angle you know and so on. So here's the way we just saw. Here's another way. In this case, see we used A and C here, and then angle B. Here we have B and C, angle A, and finally A and B, and angle C. So notice when we write the area formula for a triangle like this, we always use two sides, and then the angle that's not opposite those two sides. Basically, we're using A, B, and C, right? So look at this here. One thing to remember about this is this. So what you need to remember when using this formula is you need the following things. So for example, you need one side length, another side length, and the angle in between. That's the only way you can use this formula, if you know a side, and this angle. This one, for example, is angle A, so it would be this version of the formula here, right? And notice we need to know side B, side C. So that would be like side B, side C, and then angle A, the one in between. So that's an easy way to remember. You always need the angle in between two sides, and then you can use this formula. So let's try it out. Here is a situation where it says a farmer has a triangular plot of land in this shape. It gives you some lengths and an angle. So it gives you this length, and this angle. So does that meet the conditions I just described, where you have two sides and the angle in between? Yes, it does. So we can use this new area formula for a triangle. So try it out. Use the formula and see if you can find the area. Here's the version we're going to use because we have angle B in this case. And then putting the numbers in and solving, you should get this value here. I hope you were successful. Pretty easy formula once you use it. Now this problem is a little different. Let's read it carefully. It says the area of triangle ABC is 29.6. So it gives you the area to begin, and then it gives you one angle and one side. Maybe if you hadn't read this quickly and you looked at this anyway, you would have said, I only know an angle and a side. That's not enough to find the area anyway. So that's why reading this problem carefully is important. It's not asking you to find the area. It gives you the area. Now it is asking you to find the length of side AB. So this is the side you need. Can you use the area formula backwards to find that side? Try it now. And let's check our work. Here's the area formula, and here is the area replacing the A here, with everything else substituted in, leaving side AB unknown, and solving for that backwards. I hope you're able to come up with 20. Let's look at this one. Here we have a parallelogram, and it gives you two lengths and an angle. So parallelogram, again, remember, we talked about this. The area that a triangle is half base times height is because a triangle is half of a rectangle or a parallelogram. So this triangle is actually half of this full parallelogram's area. So can you find the area of the parallelogram? Well, the process is this. We can begin by finding the area of this triangle down here because we have a side and then another side and an angle in between. And that's what we did here. So the area of that triangle down there is 28.6. And now all we have to do is double that to get the parallelogram. That kind of brings us to this other rule here. If you want to find the area of any parallelogram, you can just use this formula. A times B times sine of the angle in between. It's the same formula we just used for triangle area. It's missing the half. And that makes sense because for the parallelogram, we no longer are talking about the half, we're talking about the full shape, so we just have that formula without the half. Okay, let's try another one here. Okay, this one maybe you're thinking I'm stuck as well because I only know one side, one angle. I can't use the formula when I don't know another side. But can you find more things about this triangle? Let's see. What does it tell you? What's a key word here about the triangle? Well, the key word is it's isosceles. And if a triangle is isosceles, this tells you more. But even if you knew it's isosceles, you need more to work with this. Maybe, well, we know the goal is going to be to find a side PQ, right? Because if we can find PQ, we can find the area. So how can you find a side in a triangle that is not a right triangle? Well, we're either going to use the cosine rule or the sine rule. So which one do you think here? Could we use sine or cosine? Which is the rule that we could use to find PQ? Well, that's the side we need. And if I set up a sine ratio, or sorry, a sine rule here with the proportion, I can look at what I have. Okay, I need PQ. I put that over sine of r equals 12 over sine of q. So sine rule is often easier to use, so I always like to try to begin with that one to see if I can use it. But here I can see I'm missing PQ, I'm missing R, I'm missing Q. Our goal is PQ, so if I can just find out what angle R and angle Q are, I can use the sine rule. So, do we know what R and Q are based on isosceles triangle? Okay, yes we do. In an isosceles triangle, the two base angles are congruent. Okay, they're the same. So, we know that this angle here and this angle here must be the same. And knowing that this is the base angle, that in other words that these two sides are the congruent sides, was essential, because isosceles triangle has two congruent sides, and it tells you here PQ equals RQ. So it tells you these are the two sides, therefore these two angles must be the same. Now, if you know two angles in a triangle, you can always find a third one. So 180 minus the 2 you have gives us 58. We have the third angle. Now we have all the angles. Once you have all the angles, sine rule, easy, good to go. Let's try this. This is going to find PQ for you, and once you have PQ, you can find the area. So try it out. Okay, so here's the sine rule set up with those angles. PQ is 12.37 or 12.4, and then the area formula applied gives us 64.9. So notice this triangle area formula often is a multi-step problem where we need to find angles or sides first using what we know already, like sine rule or cosine rule. Let's try one more here. Okay, so here we have a vegetable garden. All we know about it are the side lengths. No angles. So with no angles, we can't use the area formula for a triangle. With no angles, we can't use the sine rule either. But we know from learning about cosine rule that when you have side, 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 or side, angle, side, remember those are the two cases where we use the cosine rule. So how about using the cosine rule? And you can use the cosine rule to find any of the three angles. So choose an angle, use the cosine rule, and find it. And then once you have the angle, well, you have everything you need to find the area. So let's try. Okay, I'm setting up the cosine rule for finding angles. Looks like this, remember? And then in this solution, even though I wrote this rule here, well, went ahead and found cosine of another angle. So again, it doesn't matter which angle we're working with. The cosine of angle C. And remember, when you set that up, cosine of angle C, then the thing that you're subtracting here has to be the opposite side, and otherwise you fill in the other sides here. So there's the cosine rule, produces this angle for C, and again, maybe you found A or B, so you can have a different answer there, but it doesn't matter which one you found. As long as you then use the area with that angle, you should end up with the same area that is given here. I hope you had success with that one. You can do it. We will see you soon. You are now equipped with lots of knowledge about how to work with non-right triangles. Great job.